10時半始めましょう。じゃあ次は弁能さんにグニコーンの内容についてお話をいただきます。じゃあ拍手の方よろしくお願いいたします。
Hi everybody, I'm Benoit. I'm pretty excited today to be there to present you Gunicorn, the way we are solving the thundering out problem and the concurrency challenge we are playing with. And I have also two other big things I want to show you. The first one is how we integrate the framework in Python now in the next version. And the big change that is coming in Gunicorn, we are making it completely pluggable, and we are creating a new organization on GitHub. So everyone that is working on Gunicorn with the project will be able to store it there and know to let it known to the other people. Just quickly introducing myself, I'm doing consulting. I'm also launching a new project which is named Campio. I'm doing open source for living. I'm working, obviously I'm the author of Gunicorn, but I'm also doing a lot of code in Python and also in Erlang and in C or whatever the language fits. And everything is open source. I used to do a lot of work on CouchDB, which is a documentary database in Erlang, but now I'm about to launch a new database in Erlang 2 that I will launch, and I already shown in June. So first, let's go back to the topic. I will just have had a quick glance on Gunicorn design, because I think it's important to know how works Gunicorn, so you will be able to choose the right strategy to scale your WSGI applications or your TCP application using Gunicorns. So Gunicorn design, this is a pre-fork worker model, which only means beyond that we are sharing socket between OS processes. I will show you later how. The other feature of Gunicorn is that we are supervising every worker, every OS processes. We are making sure that they are alive, that they are not too much busy, that they are not leaking memory, etc. And we also allow, and we always allowed to have different kind of workers, so you can choose a different strategy depending on your stack, depending on the platform you want to deploy, depending on the concurrency framework you are using, etc. So first, what is sharing socket? Basically, a web server or any test server is one thing. We are opening a socket, and we are starting to listen on the port with this socket. And when a connection is coming, you have to accept it, so you can handle the connection, starting to receive your data and sending data to the clients. And the perfect worker model is about to launching processes from the arbiter, which is the main threads. And we are the main thread, the arbiter, is starting to listen on the socket and span new processes and share with them a socket, this socket. Accepting is not done in the arbiter, but it's done on the worker side. So, which means that you are able to accept multiple connections at the same time in parallel. And really in parallel, you don't have any guild problems like you can have in Python with threads, because we are in the OS here and everything happens on its sides. So, like I said, each worker waits for a connection, accepts the connections, and when a connection happens arrive on the socket, it's first put in the backlog from the OS, and the OS, the operating system, is balancing the socket between between the OS processing that accepts these connections. A synchronous worker can only accept one connection at a time, but you can accept multiple connections if you want, if you are using an async workers. So even with the sync worker, you can already make some optimization when you want to scale your connections. You can play with the backlog. The backlog is a settings in Gunicorn that allows you to set the number of connections that will be queued by the OS before starting to forbid, to reject any new connections. And so you can set the backlog, you can set the number of workers, the number of connections you want to accept in parallel. And by default, we are setting the number of workers to 2 to 1, but I should advise you to set it to 2 more, the number of your CPUs plus 1, so you can really balance your connections. Because an odd number is better to balance rather than a pair number. And which doesn't mean with a synchronous worker, some people are saying we are just listening 3 connections at the same time. We can just handle 3 connections at the same time. That's true, but that doesn't mean that you can only accept 3 connections at the same time, because you have the backlog. And the larger your backlog you have, the larger you can accept connections to your sockets, because the system will put the connections that are coming in the queue, and your worker will pop it from the queue from time to time. And yes, on top of that, you generally have a proxy that is able to buffer. We used to advise NGNX, but today you can proxy your Gunicorn with Apache proxy, because it's able to buffer today. You can also use, and this is very well done with HE proxy. With HE proxy, you have also the possibility to use the proxy protocol. And the proxy protocol is handled by Gunicorns, which means that you can pass connections directly from your proxy to your Gunicorn and have all the power of HE proxy. That's all. When we are seeing monitoring, supervising workers, we are basically seeing that. So we have our workers that are live, and from time to time they are notifying the arbiter that they are still alive, that they are not busy, that they are able to notify him. And they are doing that by updating a file. So the first time a worker is spanned by Gunicorn, we are also creating a file, a temporary file that is shared between the arbiter and the worker. And when the worker is updating the file, is chmodding the file, in fact, he's not putting any data to that. He's telling to the arbiter, hey, I am alive since such time since last time, etc. And the arbiter is checking that with a timeout. So if a worker forget to notify in the timeout, it will be killed by the arbiter. And this is a very conservative model, so we are making sure that we don't have any worker that can be busy and don't accept a connection 4 times. So if you want to accept longer connection, you can either use an asynchronous worker or increase the timeout. Like to handle big files, or if you know that you have slow connection to your database. And so just to summarize the arbiter workflow, so we have signal, OS signal this time up, or USR2 or USR1 or kill that are sent to the arbiter to either upgrade Gunicorn gracefully or kill it gracefully. Signal are not handled directly by Gunicorn. They are instead put in the queue asynchronously. The arbiter is running in the loop, and the loop the first time the first action it does is checking the signal queue, and if there is a signal under it, so if it's up, it starts to upgrade Gunicorn and reload all the worker connections. And other actions. And if it's empty, then it starts to manage the worker. It first check if a worker forget to notify him, and then kill it, if any. If you have too much worker, because it can happen that you have too much workers than expected, then it kills them. It kills the oldest worker, so you have always the number of workers you set. And the last thing it does, it's starting to manage the worker. So when you increase the number of workers dynamically using the signal, or decrease the number of workers dynamically, it will take care that the number of workers is here, either by spawning new worker or killing old worker. And why different worker? Because you may want to use different concurrent strategy in your application. So you may want to use async IO, you may want to use eventlet, you may want to use G-event, Tornado, Twisted, whatever you want, libuv. You have a worker for all, and you can use different concurrent strategy for that. You can also use some stuff, some low-level things like mineheld or UV green that are using greenlets or fibers behind that in C code and providing worker in C code for Gunicorn with CPython. You may want also to support different platforms, so you may want to use a worker that is working on VMware and optimize for VMware, or you may want to use a different worker for depending on the OS. Or you don't want to handle WSGI. By default, all the workers of Python Gunicorn are speaking WSGI. But if you want to have your own HTTP server or any TCP server, you can just use Gunicorn and provide your own worker, and you will have a TCP worker supervised by Gunicorn. And yeah, you can do more probably. So the thundering herd problems. What is the thundering herd problems? The thundering herd problems is basically happen when all the processes are waiting for the connections, and they are all awakened by the same for the same connections. So they will all accept the same connection, but obviously you can have only one worker that is able to accept the connection. So all other workers, those who didn't really accept the connection, will trigger again error, and then you will have to Gunicorn have to catch it. And it increases the CPU usage for nothings. It is using the memory for nothings, and at the same time, the worker that doesn't accept the connection are busy not accepting other connections. So this is what we call the thundering herd problem, which Dynamic is really good, Thunder, giving a lot of noise, because this is a lot of noise. A lot of people have speak a lot about the thundering ad problem, but this is not really a problem today if you are using a modern OS and you are listening on one socket. The OS already take care for you to make sure that only one process can accept at a time a socket. This is not true anymore in modern Linuxes in latest version of FreeBSD or NBSD, OpenBSD, I don't know. But this is not true in modern OSs. But this is still true because in Gunicorn you can listen on more than one socket. This is still true when you have more than one socket, because when we are listening on multiple sockets, we are just doing the simple path. We are putting all the socket in a select loops, and we are looping over the socket that we can accept. At these times, you may have accepted a socket and another worker has also accepted the same sockets. You have some race condition here. And then you have the thundering ad problem. So we have to fix it. And this is fixed. The discussion happened in the ticket 792 in the Gunicorn tracker. And we are solving it very simply. We are introducing signaling between worker and arbiter. And I'm speaking about signaling using a pipe and our own messaging system, not OS signaling. So the arbiter will check if a socket is able to accept, then mark it that a connection is arrived and that a worker can accept it. And worker, when they are not busy to handle the connection, will ask the arbiter to take a connection. They will just basically saying to the arbiter, "Hey, I'm able to accept. Give me a socket," and the arbiter will send him a socket if any. Or if the worker is busy, he will continue to notify and send message to the arbiters using the pipe, saying "I'm alive." So this is basically done in this schema. You have the arbiter, and these times you have no notifications, no temporary files that will be removed. You don't have you have message from the arbiter to the worker and from the worker to the arbiter. But we are still keeping it very conservative. This is not the arbiter that is asking to the worker if he's available to accept the connection. This is the worker that is stealing work from the arbiter. So you don't use too much CPU, you don't use too much memory. This is very simple, and we can continue to supervise the worker as we did. And because we have only free message for now, we can extend it later, of course. You have the arbiter that is only sending an accept message with a socket that on which a worker can accept. And it is only sending this message when the worker has sent a message that he is able to accept this one. And the rest of the time, the worker is sending this message to the arbiter saying he's alive, with a timestamp, so the arbiter can check if something is wrong or not, depending on the time. So of course, it introducing complexity. The arbiter has new jobs. All the worker will need to be updated. So by all the worker, I mean all the worker, not the worker, event-led worker, G-event worker, mine-led worker, whatever. They all know to handle the new signaling API. And we will try to provide a new helper models before the end of the month, so every worker will be able to upgrade. And I don't expect to have a release with thundering help problem solved before the end of October. But this is planned for 9.2.0. Possible optimization, because like I said, we don't need all this stuff for one worker. We can just continue like we does, letting each worker accepting without signaling they want to accept to the arbiter. So the arbiter won't send any message. That will be pretty simple. We will keep the pipe for the alive message, but that's all. Depending on the load, we can also maybe bypass the signaling. So if you have a lot of connection, there are likely chance that you have the thundering problems. So we will be able to have heuristics to just say bypass the messaging. Don't use the messaging at all. Free the arbiter from that. We accept that when we have too much connections. When we have less connection. A letter optimization is to provide another way to share message using memory message passings. But this will be under letter by a library I'm releasing right now. I'm working on right now, which is offset, and it depends on that. So one command to rule them all. Until 18, sorry, because this is deprecated now, you had to use many commands with Django and Pastor. You have the Gunicorn Django command. You have the run Gunicorn command from the Django command lines. You have the Pastor server from Gunicorn. You have the Gunicorn Pastor command. And in Flask, you have specific code to handle Gunicorn inside the Flask server, etc. We don't want that. We want to offer the best experience to the user. We want to make sure that every user has the same experience, whatever the worker they are, whatever the framework they are. And for that, we will only use now one command, which is Gunicorn. So no more Gunicorn Django, no more Gunicorn Pastor. We are fixing the preloading issue because when you are using the Pastor server, when you are using the Gunicorn run command server in Django, you were preloading all the workers. So you were using the preloading option without knowing it, which made a lot of users wonder why they couldn't upgrade in live their workers like they can do with a normal Gunicorn command. This is because of preloads. And other thing we added for Django, for Pastor, was all the code to handle the configurations issue, to handle the settings modules in Django, which is not really Pythonic. All the things to make sure that the database is loaded with Django in Gunicorn, etc. A lot of code, a lot of duplication from the work that is already done in Django. And Django was kind enough to provide a new WSGI way to launch the Django application, so it helped us a lot. And in Pastor, we still need to do some hack to handle configuration, but this is quite small. So all these commands disappear, and in October with the new release with 22.0, every old command will have disappeared. So if you are still using them now, it's start to think to change the way you are doing it. And we want to do that. We added 3 new settings, maybe more now. We have the pass setting. The pass setting is doing specific stuff for Pastor. It's loading your configuration file, your configuration Pastor files. It allows you to choose one of the application you set in your configuration file, because in Pastor you are able to set a lot of configuration, a lot of applications. So you can use the pass settings just like in UWSGI and other server. We added the Python path, which set the Python path environments, which says where are the Python modules, the extra Python modules that are not installed widely on the systems. And we added the environment settings, which allows you to, for example, because Django is still not really Pythonic, in Django you need to set the settings using the settings environment variable. So you need to set the env, and now you can use the env commands. By the way, we used to have a settings variable, settings arguments to Gunicorn, which is also deprecated today, and which we also removed in 22.0. So only one command line in 22.0, so in October, and be ready for that. The last things I want to talk to you about, this is really a big thing, a really big change for me at least, We want to enhance the user experience. All the discussion is handled, has been handled in the ticket 837. So you can find all the detail in that. So today in Gunicorn, workers are already pluggable. So you can add your own worker to Gunicorn if you want. Loggings feature, like today we have estate, we have syslogs, and we have basic Python login configuration. All of this is already a plugin. If you want to add your own logging facility to Gunicorn, you can do it today. The thing is, until now, we embed all these codes in Gunicorn. So when we want to add improvement to a worker, when we want to fix a worker, or the same for logging worker, we had to upgrade all Gunicorn. Most of the time, these upgrades were pending for other needed fix to the main Gunicorn core. So the update were lagging, and users weren't happy. I wasn't really happy, sometimes frustrated by that. So the best way to do that is to put out all these plugins and provide an easy way to reuse them in Gunicorn. So this is not coming from now, but we are creating for that, to handle all this work, we are creating an organization on GitHub. All the Gunicorn code will be moved to github.com/Gunicorn before the end of the month. And we will after that, we will start to split Gunicorn worker in each own repository. We won't do anything fancy. We will only use standard library like we used to be. We will use setup tools. We will use entry point to register plugins. We will use pip to install plugins. We won't provide our own tools. The only thing we will add are some metadata to be able to set up the environment when you install a plugin, stuff like it. Stuff that are more easy to do in Python 3 than in Python 2, but we will handle for both today. The other thing we also want, and we started with the 19.0 version, we started to add a way to allow you to embed Gunicorn in your own applications without using the command line, without the things. We want to improve that, and we want to improve that in a way that so you can use like I don't know, maybe this is not a good image, but like you are playing with 0MQ sockets mostly. You just start a Gunicorn service, Gunicorn context in your Python application and start to provide behavior or TCP behavior mostly. And everything will be supervised in the Gunicorn way, and you will be able to have hooks to reload your own code, etc. And I want to push that because what happened when we remove the plugins, when we remove the worker from the core, we have a real core, so we can improve the core and make it have its own history. So this is a work in progress, a really work in progress. The deadline is the end of the year, and I think we should be good for that. And that's all. Voilà. If you have any question. No? Sorry? Sorry?
Okay. Do you have some idea on the async IO of Python 3
Yeah.
to users backend worker?
So you already have two workers using async IO in Gunicorn 19. You have one threaded worker which is mostly working like West-REST in past. So we are using selectors that are coming with Python 3 and async IO for the threaded workers. Which means basically we are handling connection in threads. And we have a pure async IO worker, which is using GIO HTTP modules. And the guy from GIO HTTP modules joined the team of Gunicorn, so they are handling that. The only things today is that async IO worker is lagging behind the other worker because because we are putting all the body in memory right now, rather than streaming it to your applications. And this should be fixed because with a large body, you will use more memory. That's the thing. But we already have an async queue worker. You can even use the WSGI environment to take the socket and to take the don't remember the name, but everything you need to handle async queue using the same loop. Yeah, the loop.
So do you know, is there some insight in the performance?
In performance, all asynchronous worker are slower than synchronous worker. But it's equivalent to the G event worker. I strongly advise to use eventlet on Python 3 today because this is a lot faster than async queue.
Okay, thank you.
Thank you very much. And we have one more question. Any other questions? Okay, thank you very much.